So, hi everyone, my name is João Acabado. It's great to be here at DevOps Lisbon. So this is really a DevOps meetup. We have redundant microphones, and people get called out, and if you get called out, you have to pick it up. So that's a good thing, I respect that. Thanks Fujitsu for having us. It's a great audience. So today I'm going to talk you through how quantiles and percentiles can help us measure service performance. So first, a bit of context where this work was developed. So I work as a reliability manager at Sky. So Sky is mostly known as a broadcasting company. You might know Sky Sports or Sky News. Sky also manages its own broadcast and OTT video platform. So it has its offering across 7 different European countries, which supports more than 80 devices, and this is amounts over 3 billion video streams per year, or 10-something exabytes. And let's move on the marketing pitch here. So we have a technology center in Lisbon. That's where I work. We have currently more or less 200 people working on backend, being it Java, Kotlin, or C#. We have also mobile and front-end teams. So we are hiring. So if you are QA, an SRE, a systems engineer, a mobile developer, and you find that scaling a service up to 10,000 transactions per second is a great challenge, or building a search engine up to supporting up to 3 billion queries, you'll be a great fit for Sky. So why are we talking about this here? First of all, speed matters, right? 30 years ago, we would wait 10 minutes for our games to load in Spectrum. 10 years ago, we would be okay if a website took 5 or 10 seconds to load. Nowadays, if your service takes more than 2 seconds to respond, people will just run away. And that's what's happening. Then monitoring, and how monitoring helps us to do this. So you might build your own applications very, very, very fast, or be very, very high performant. But if you don't monitor, I'm not sure what do you have. So it's a Schrödinger high performance application. You don't really know, right? So you need to monitor to squeeze these extra milliseconds and to understand when things get slow. Besides monitoring, if you just do lots and lots of monitoring, you have to have the right visualizations. So the right visualizations will be the ones that help you understanding the monitoring data, to react quickly to it, and to be able to adjust correctly, and making this in an accessible way. As we are seeing, it matters that lots of people, or most of the key people, are able to understand what's in place and what's happening at each moment. Let's brush up our statistics. So we have here a population of 20 individuals, so they are sorted by 8. We are interested in understanding their age distribution. So we have that the percentile 80, or 80th percentile for this population, will be 1 meter and 85. And in the same way, the quantile, which is just the inverse function of the percentile, will be the quantile of 1 meter 85 will be 80%. So the percentile tells us that 80% of the population is under 1 meter 85, and the quantile tells us how much of the population is under a certain age. In this case, 1 meter 85, it will be 80%. All good? Okay. So let's translate this to a service. We have here our user, which is always on the run. He's calling the REST API on A, which is calling a service B, and then we have a database behind this. Doesn't really matter for the example, but let's have it. And then we have here a bunch of requests. So the first request took 200 milliseconds. Then the second was a bit faster. The 2 following requests were a bit slower again, then a bit slower, and then much slower requests. So we have these 10 requests, and how do we understand their response time? So we'll be focusing here on response time to understand the performance of the service, but there are many other metrics. So we have that the percentile 80 for this sample of requests is 609 milliseconds, and we would have in the same way that the quantile of 609 milliseconds will be the inverse of the percentile, so 80%. So here we are trying to explain or to understand the response time of our application in a given period with these requests. And this is often the exercise that we want to do. So let's try to visualize this in a much better way. So this is the same data, and I'm just staggering because we have some kind of visualization problem. And the first, if you are attentive, the first request might be missing. But here we have the request sorted by response time. And once we do this, doing the visualization of what is the percentile and quantile becomes much easier. And this is what any algorithm for percentile and quantile will be doing. So the percentile, given that we have 10 requests, will be the 8 requests under the 8 first requests. So or the value under the value for which the first 8 requests are, which in this case will be 609 milliseconds. And then let's say we want to qualify the performance of our service. So we would like to have an objective for our service, and we have a customer. It's Lloyds Bank, very important, and they are very demanding. And they say, so any request. So they saw our Grafana boards, and now they are saying any request over 600 milliseconds or 609 milliseconds, it's completely unacceptable. So let's say we set up a service level objective for this. We could then quantify how many requests do fulfill our objective. So this is how the percentile and the quantile help us have insight into a distribution in different ways. So the percentile would give us this insight into how much of the requests were served under a given time, and then the quantile would be how much of the requests were served under our service level objective. Something to note here, or to highlight, I would say, is that if we use something like the average, it wouldn't really help us, right? So we are using percentile, or the percentile is very used for this, because usually we are looking to understand the extremes of our population, right? So we are perfectly okay with the very fast requests. The slower ones are the ones that bother us, and that's why we usually target the higher percentiles. So percentile 80 is not something very common. You usually do the P90, P95, P99, and so on. But if we had the average, given that there is this unbalance, and usually it's not a uniform distribution of response times, it wouldn't give you the same information, right? So now going to a real-life example, and we are on the same page with screenshots of Grafana boards. So this is a Grafana board as well. So what we have here are 2 service level indicators and the service level objective for a production service. I see my colleagues are like saying I picked the wrong example. So yeah, so this was not behaving in its best, at its best, but I wanted to share it with you. So first we have here 2 service level indicators. So we have the P50, also known as median, right? And then the P99. So what does this tell us? This is telling us that on the median, that 50% of the requests were served under 281 milliseconds, and then that 99% of the requests were served under 2 seconds, which is not that good, right? So, but what we have done, and what we have done here on this board and for all our services, is to define service level objectives. So in this case, the service level objective was 1,000 milliseconds. So if you see here, this is the Grafana variable, and we have the pipe, and after the pipe, we use like a kind of an annotation where we have the service level objective. What we have then on this red panel over there is that the service level objective for the service response time is that on the last day, this service was able to respond 84.31% of the times under the service level objective. So we don't really know how slow were the other requests, but we know that 84% of the time we achieved our objective. That's not good at all. and that's why neither one or the other neither one or the other measures are enough by themselves. So what can we say about these measures? So the quantile that we are using for the service level objectives is a relative measure. So it's between 0 and 100%. It does help us create very, very easy color coding on Grafana that we can see on the dashboards. And it's also easier to reason about when you are comparing different time ranges, which is what we're going to see in the next slides. So for the service level indicators, what they give us is an insight into the distribution. So it's an absolute measure. So it will be, we have there 281, it will be 700. It really depends on the service. But what they do give us, so while the service level objective told us that 84% of the requests were under 1 second, if we wanted to understand, so how bad were the other, I need to do the math, so 25% requests. So at least we know that until 99% of the requests were under 2 seconds. So this is how both measures can help us have an insight into response time. Just to add something else in regards to the service level objectives and how to define them. So in an ideal world, you'll have your product owner, you'll have your customers, you'll meet with all of them, and they'll tell you, so these are our expectations, this is what we need for this to fulfill our objectives or our expectations. It doesn't always happen. So what we have been doing, and I think that has been working well enough for us, is to look at recent history data and then try to tune the service level objective. So if you are worse than you have been before, it's a good indicator that your service is, the performance is degrading, right? So now we likes microservices. Nobody? Nobody likes microservices? 1, 2, 3. So we builds microservices. Well, not too many people as well, but that's okay. But if you like microservices and you build microservices, you'll end up with lots and lots of them. So what we have here is like a sample of 5 microservices. We actually are running 22 side by side. And it's okay if you like microservices. It's also okay if you don't like them. Sometimes I don't. But when you build too many of them, you better have a way or a framework to monitor them and to know what's happening with them. And we try to standardize it in a way. What I wanted to highlight here in this dashboard is how having the different measures can help you do this, right? So first of all, we have completely different microservices. So starting on that end, so on the rightmost, we have the calsky plus rex. So that's a very badly performing service nowadays, which, well, it's still an indicator. The indicators are there to be read. And you can see, so it's very low volume. So the peak transactions per second was 1.7. While if we compare to on this end of things, we have very high volume services. So the second last one, we have a peak transactions per second of 3,000 requests per second. So this will be the daily peak transactions per second. We can also see on the first row, you have the percentile 99, and we have services that do take in seconds. So we have for the first one, 4.83 seconds, while these ones work under in the milliseconds range. So binge viewing works under that 10 milliseconds, and Falke here is working around 30 milliseconds. So it's your service doesn't need to work in 10 milliseconds. It completely depends on the service. So you can be making requests to a very slow service, and there's not much you can do about it if you have to do it synchronously. Your service can be doing very expensive stuff, either in memory or in the database, so that's also okay. But the only way to be able to reason if your service is doing is doing it in the expected time is to have the service level objectives. And that's what I wanted to highlight. So given that we have defined service level objectives for all of them, and that we are measuring their performance, we are then able to compare their actual performance against the expectation. So what we have there on the second row is the service level objective on latency, and this will be compared to each given service level objective. It will give us how many times did the service fulfill its objective. So this brings us to another topic. So we have been mostly talking about service performance directly when making API requests, but there are many other sources of complexity in our services. So the EastEnders, don't know if you know about it, but the EastEnders is like a very popular soap opera in the UK, which has been running for almost 30 years. So it happens every day at 8 p.m. And so I don't believe it's as popular right now as it was like 10 or 20 years ago. But what happened 20 years ago is that everyone watched it, and everyone was glued to the TV when it was happening. And as I was told, it was a very dramatic soap opera. So when it ended, and people stayed glued to the TV during the EastEnders while they were watching it. Then when it ended, everyone got up off its couch. They turned on the kettle, and then they opened the fridge because British people have milk with the tea, which is something weird, but that's what they do. And what happened is that this created like a temporal effect. There was a very, very big spike into the electrical grid, which caused outages many times. So around 20 to 15 years ago, this was a real problem that the electrical companies in the UK had to deal with. So nowadays, we don't have this problem as much because hopefully people use streaming services, but we still have the same problem in our streaming services. So the kind of effects that we see are the ones caused by people being coordinated around events, be it football matches, be it like a big event where everyone goes to react to that event afterwards. It can also be the natural rhythm of each city or each population that does that, and we can see that on our services. So usually our services don't break when they are at their lowest usage. They are affected when they are at peak usage. So something else that sometimes we do against ourselves is that automation is also a big source of temporal patterns. So this is the DevOps meetup, so we like to automate everything, but automation also creates patterns, and if automation can go wrong, not sure if you have watched it, but I have an example of it. So what we are seeing here is like, so this is the response time for a given service. So actually this is the voice search service on Sky set-top box, and what we are seeing is like for a given set of days, so from the 26th of July to the 31st of July, we are seeing how the response time performed during these time ranges. So the response performance is split into periods of 30 minutes, and then we try to compare. So on each value, we have the quantile of 3 seconds. So this is how many of the responses were served under 3 seconds. So an higher value is good, a lower value is very bad because 3 seconds is a lot. Actually, the box just gives up on doing this. So, so this is the example of how we can use relative measures to detect and to observe the temporal patterns. So we can see that at 10:30, we see a very definitive temporal pattern. We can see that at 14:30, we also see one. I'm skipping one there on purpose, but then at 20:30, so this will be the EastEnders effect or something like that. And then we can see at 10:30 that this is also happening. If you are looking for it, so we can also see that something very bad happened in that day. So things started to get slower and slower and slower and slower, and they usually break down. So hopefully somebody did something to restore them. So this was a very long troubleshooting session around nobody was understanding what was causing this. It didn't correlate with organic usage. So we started suspecting so this might be something, some background process, something that is happening that is causing this. So once we split our traffic, this is the traffic pattern for a given day. Yes, for a given day. And so since 8 a.m. to 8 a.m. of the following day. So there in the middle, you can see so that's the peak usage. But at yellow, you have another line. So that was traffic being generated by a background process. So actually, it was the set-top boxes that were re-ingesting the catalog, not in the best way. And we can see, so 10:30, then here at 14:30, again 20:30, and that last spike. Although the latest spikes were actually originated by the users themselves, while the first ones were not. So this is what I wanted to highlight in terms of how different patterns or how different usage can be mixed together to give very confusing signals, and sometimes you are looking at your system and you don't really understand what's happening. To sum this up, so tools to implement this. So you have seen Grafana and InfluxDB. We have Kibana together with Elasticsearch to look at logs. So this last graph, not the last graph, but the temporal analysis was done on Kibana. It supports Quantiles. You have Graphite or Prometheus as backend stores for time series, as you can use in InfluxDB. Then I just wanted to highlight two techniques because I think that if you are looking into this, it's very useful to know since the start. So preserver sampling, which is what Drop Wizard uses in most of its implementations for response times, and then histograms, which is like InfluxDB and Prometheus take a big advantage of it, and it's just like a smart statistical sampling to understand this without wasting too much memory. If you are really looking into this, and I tried to do the how to measure latency, but if you are looking how not to measure latency, so there is a very known talk from Gilles Tin, which you used to be looking for it. And then how to do this? Well, just build it and run it. You'll face into the problems and you'll have to solve them at some point. So my takeaway will be that you set service level objectives for all of your services, and if possible, for all your dependencies, because they are your dependencies. And try to simplify your visualizations as much as possible. And that's all. Any questions?
Have you tried looking into timing between service degradations? And if so, is it true that trouble never comes alone and troubles come in packs?
Yeah, it's very true. It's mainly in microservices. If somehow you end up with common dependencies, and mainly also on co-located services. Also with microservices, it's very easy to observe. So you'll see that the DNS problem will have a certain pattern. You'll see that the network degradation will have a certain pattern. You'll also see that the waves of alerts when storage fails will come in a certain way. So yeah, so it's hard to make a science out of it, but it's a very important way to troubleshoot or to understand what's the root cause, having all the services side by side and understanding what's common between them. If it's a network context, if it's a firewall, it's the storage, but yeah, but that's very important, I'd say. Any other questions?
Yeah, did your POs, product owners, define the SLOs correctly? Or?
No, we don't live in an ideal world as well. No, we define them ourselves by looking at the historic data of the services, mostly. So something we didn't do in the beginning, which was trying to set up the expectations for our dependencies. So, and even if you don't do in a very formal way, like even if you ask like you depend on a certain service, and you ask them and they don't give you like an SLA, we would say, I think it's good that you tell them, so I'll be expecting that you never answer in more than, let's say, 2 seconds. And then you can set up a timeout at 3 seconds or to 2 seconds and a half. And at least from the beginning, and I think that should be done in the beginning of the conversation before you do the integration, at least from the beginning, you have set up an expectation and you are able to provide monitoring that they can understand, and they don't ask later, why did you do something like that?
And who sets up that monitoring, the requester or the provider?
Usually, you have to do it by yourself, no matter who you are. But we had, so that's also something that's interesting, because sometimes we have dependencies and we reach them and we tell them, so you are being very slow. And they show us so some other teams in Sky, and they show us their monitoring and they say, we are very fast as well. So we have to take into account, so we are all working in distributed systems, and the network is always a factor, no matter what. So I would say that's important that everybody sets it up, or there's not, unless you have some kind of canary request that you can compare to, or something like that. So I think everyone should be involved in the conversation as much as possible. It's not that usual, but I believe it might be in the close future.
So do you define, this probably is also between B2B and B2C customers, do you usually define your targets so that you can get 100%? Or do you define the target and you know that in general you're targeting 99% or 99.95? Because you can define the target and then look at the objective, or say your target is this latency at this percentile.
So an hard limit for all of this is always, so if you have a chain of requests, which you should try to avoid, is like the timeout, the overall timeout adds up in the end, right, to the customer. So we had these hard limits, and while we didn't do one thing or the other, it really depended on the situation. I think the interesting thing here is, so we had these not so performant services, like, so the first one we had there, and we had like targets for these, like around 600 milliseconds and 800 milliseconds in 1 second. And what ended up happening is that this has driven our architecture. And what we are doing nowadays is, instead of doing synchronous requests to other services, we are doing lazy loading in memory. So we just load the whole catalog and we avoid to do these requests. So I would like to say that the monitoring in some way has driven us to be able to set up much more ambitious latency goals. But, well, trying to answer what's the best way of doing it, I think...
It was not the point of the best way, but in fact, how do you define it? It's a bit aligned with the question of it's the PO or not, but if you are targeting, because basically when you look at historical data, you might be defining a goal that either by business doesn't make sense, and in fact the POs will probably say that this makes sense, or in fact with certain changes you could do much better, but then you are basically padding your objectives to what you have.
So I think best way would be to look at a good period of your application, so a multi-day period, and try to target that, and then at least your monitoring will be useful to detect when it's not a good period. So that's what I would say, but it should be a multi-day period. So it's very easy to perform very well at 2 a.m., right? But if you look at a very good period, and then these can be useful to detect any other causes of delays or slowdowns. That would be the best way. Any other question?
All right. Can I ask probably one question for both that we're presenting? Because you're doing the monitoring, but at some time there's a bill at the end of the month to pay for the cloud consumption. So are you using the monitoring also to scale up on the surge events, or to shut down servers and keep the SLAs? always through the day, or
I'm not doing it, and I don't believe too much into it, but if anyone is doing it, I'll be very interested.
So in our case, especially because you are targeting, or we are targeting percentiles that are very high. Even I don't think we have a single customer just with 99. So it's everything above that. It's basically, it's either you are, let's say, predictive of, you know that an event is coming and you need to scale up proactively, but not by monitoring, because in fact, you will, in our case, we have surges that, for example, there are some clothing stores that they launch these events, and you will see, for example, at noon, suddenly it goes from 1 2 TPSs to 300, 500 just in 2 or 3 seconds. So you cannot have monitoring basically predicting for that. And it's just the nature of our business. We use it mostly for especially systems that are maybe oversized, but more in a, let's say, less informal way. And even basically, in our case, we use AWS. They also do it for us. They will send us alerts saying this system can be scaled down and so on. And we need to decide. We don't do it automatically because, again, especially because we need to ensure certain SLAs. And most of the times the systems are a bit oversized to make sure they can handle with those surges very, very fast.
Where I think it really helps, sorry, but where I think it really helps is in capacity planning. So if you don't have any of this, and you really need to support the load, you'll end up oversizing a lot. I think if you have this, you might oversize just the right size. So reacting instantaneously, I think it's still like a pipe dream that everyone is talking about, and cloud companies are selling the pipe dream. So with this, we are not only able to correlate like the availability and the performance of the services with the resources that they are consuming, we are also able to understand the efficiency of a given service. So for a given capacity, how many requests is it serving, and in which and with which performance. So I think it's still very useful, even if it doesn't do that. So, but I think we might have a talk in a future meetup around that.
I think it's a kind of a multi-dimensional criteria that you have to use in order to get that stage. The technology is there, of course. You can use autoscaling from AWS and things like that, but only from the latency perspective shouldn't be enough. You need to usually cross that information with your resource utilization, things like your CPU utilization, memory, network packages, and things like that to get to that stage. So it's not a very simple answer to that.
And you need to have your fallbacks very well configured as well. So if you do any of this automation, I was just reading about one of these cases. So if you don't have the information, you cannot just assume that you'll be shutting down of it's now slower. So if you don't have, if your automation doesn't have all that information in a multi matrix kind of way, you need to assume the worst, and you need to scale up, and that's why it's so hard to save money. But well, I think the cloud companies don't want us to save too much money as well. Okay.
thank you guys.
Thank you.